Hi everyone, thanks for tuning in to the Developer's Guide to AI. My name is Henk Boelman and I'm a cloud advocate at Microsoft. And for this presentation, I've invited two of my colleagues to show you how you can get started with AI as a developer on the Azure platform. You might wonder, why start now with machine learning as a developer? Me, as a developer myself, got started with machine learning a few years ago. And in those years, I've seen that an AI component is getting more and more common in modern applications. From speech services for intelligent bots to specifically trained models for instance, anomaly detection. So I think for a developer to get started, you have to go to 3 stages. So first, you need to understand what machine learning actually is and what it can do for you. Second, you have to get yourself familiar with pre-built AI systems like our cognitive services. This is a suite of services of around 42 that are divided in 4 regions. So there is vision to make your application see. There is speech to make your application listen and talk back to you. There is a language so that your application can understand what is being spoken, and there is knowledge to give your application a brain. There are also some services that are in between. So there is a custom vision service where you can bring your own data and the service will do the work of training your model. There is also the visual designer where you can drag and drop your own machine learning algorithms and publish them. And there is automated machine learning that will help you pick the right model. So the third one is to do it all yourself. So there are always some scenarios where a pre-built model will not fit, and that is mostly around 20% of the cases. So then you can use the Azure Machine Learning platform. You can bring your own data. You can bring your own training script. And Azure Machine Learning will help you put this in production and create a repeatable, traceable process for you. First, in this talk, I want to dive into what AI actually is and how it works. So I've invited my colleague Seth Juarez that will give us a quick insight and understanding what AI actually is and how it works on Azure Machine Learning. Hi Seth, thank you for joining me. How are you doing today?
You know, I am doing great.
I've just been talking about how developers can start using machine learning on Azure. So I'm curious, what is your favorite part?
So my favorite thing on Azure has to be being able to train custom models any way I want, with any technology I want, and have it be able to be a repeatable process, number one, have it be able to be, number two, shareable so that everyone can see what I've done. And then number 3, I can actually output whatever I've done into something that other software developers can use pretty quickly and in a wonderfully cloud native way. It's pretty cool.
Now let's get started with the big question set. What is AI and what can it actually do?
Yeah, so many developers ask me, well, what is AI actually doing? And when I talk about AI, I talk specifically about machine learning. So I want to make sure to give that caveat. But generally, when we think of programming, we have this notion of we are making a function. I'm going to generalize a lot, but let's just boil it down to we're basically building a function that takes input and outputs answers. And now we have a bunch of functions that work together, and sometimes we use functional languages, sometimes we use dynamic languages, sometimes we use object-oriented, but down at the minimal level, we create a function that translates some input into some answer. And it turns out there's a class of problems where this is not so easy. I like computer vision, and imagine having to write an algorithm such that when you look at a picture of a taco or a burrito, which I'm going to show you later, imagine being able to build an algorithm that tells you that's a taco, that's a burrito. It's a hard function to write. And as you imagine as a programmer, you think of, well, what do I get when I get a picture? Well, it's basically a bunch of numbers. Like for every pixel, there's 3 or 4 numbers if you have an alpha channel. How do I take those numbers and make them into something that makes sense? Like this is a taco or this is a burrito. And so machine learning, what it does is it actually flips the script a little bit. And instead of creating a function, we give the computer the answers and the input, and it produces a function. Now, these are not, we don't call them that in machine learning. we call these things models, and then the input is data. Now, this is the critical bit. When you hear of a machine learning model, I started as a programmer and then did machine learning. I think of a model as a function that's just written in a different way. And instead of having to think about the actual algorithm, you instead give it data, and then it produces an actual model. Now, the question is, what is actually happening in here? And that's a really good question, because it seems kind of far-fetched and actually kind of magical. And so what I've done is I've actually decided to show one of these things in practice. So here is some code. And basically what it does is it creates a model for you by shoving a lot of data in it. And if you're thinking, oh, well, where is the data coming from? For me, it's this, right? So there's some burritos. So let me reveal this in Explorer. It's basically pictures of burritos and then pictures of tacos, right? This is the data that we're giving it, and it's supposed to produce a function. Now, it seems kind of magical. It's not going to make a function by itself. We actually have to give it a function shape, right? And inside of this shape, there's a number of parameters that then the computer can optimize to produce the right answer. But we have to give it a function shape. In this case, I'm using this thing called a ResNet, which is a standard machine learning neural network, a deep learning network, and it has 18 layers. And then what I'm doing is I'm adding an output layer that matches what I want. In this case, how many classes there are, and for me, there's only 2. Tacos or burritos. And then I give it some measurement of how bad it is at doing it, and then I train it with that thing. So basically this function says how bad are we at it, and then this right here optimizes it to minimize the loss, and it uses calculus and other various fine sundry things to do that. So if you want to see what it looks like when it runs, that's a good question. I could run it. It takes a couple of minutes. But basically, we go through the data set, the pictures, n number of times. In this case, I chose 4, and that's what an epoch is. And this is looking at every picture or every batch of pictures. We give it a couple of pictures at a time. It says, how bad are we at it? And we want this number to go down to 0, right? Notice that it fluctuates with what's going on. But basically, we want to drive this number down to 0 because this tells us how bad we are at it, and we want it to be 0. And then this tells us how accurate we are at the training data. So it looks like I got to 72% accuracy on the training data, 80% accuracy on the validation data. What does that even mean? Well, there's no way to test if this works. And so as I have a large set of tacos and burrito pictures, I use a subset of them to train it, and then I use another subset to see how well it's doing. Well, this is all well and good, and I haven't really told you about the cloud yet. Before I do that, I do want to show you what it actually produces, because this is the actual function. So let me go over here, reveal this with Explorer, and let me click on this. There's a special program called Netron, which lets us look inside of these neural networks. And basically notice that the input that comes in is this thing. And you're like, well, what the heck is that? Well, it's a picture that's 224 by 224 wide that has 3 channels and RGB, red, green, and blue. And then what it does is it basically starts multiplying it by numbers that it figured out during the optimization problem. And I'm being serious. Like this isn't a very deep one because I wanted to train fast, but it's literally numbers that it learned. So if I go over here, these are the numbers. As it goes down this network, it's like, we need to multiply this by these numbers. And then out comes this thing. And then there's a vector that comes out of size 2. And what happens is it's like that old game Plinko. If you've ever seen Plinko, it's like this game where you put a little like a little round thing and it goes boop, 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 and it goes down. Basically, the picture goes down this thing and it gets subdivided and multiplied and whatever and filtered down. And so it ends up with 2 little buckets at the end. And the one bucket represents a burrito, and the other represents a taco. And the number that's the biggest tells us which index it thinks it is. So this is to me kind of cool. These neural networks are actually much more sophisticated than this now, and they're much bigger, and they do a lot more cooler things. But the reality of the matter is that training these things in a repeatable and reliable way depends on a lot of stuff. Like, for example, I had to create a special conda environment. I have to have a special things set up. And for someone else on my team to replicate this would be hard because I would have to give them, this is how my machine is. So the beauty of the cloud, now that we can get to this, is that it allows you to run these things in a repeatable way. So this is the same thing, only one epoch running in the cloud inside of Azure Machine Learning. And what's cool about this is that it runs it in a container so that it's repeatable every single time. And not only that, you can see actual metrics. So here's the loss over one epoch. It's going to fluctuate this way. And then the larger you go, the more epochs you'll see the loss goes down and the accuracy goes up. So for example, let's see if I can find, there we go. So there's the accuracy. There's the training loss. But you would get more numbers. I only ran this one time because I wanted to show you what it was like. The other cool thing about this is you can actually output things like images. So for example, this is a validation run that's showing me what it predicted for each of these things. And when I wrote the thing, I output these images. Now they're all here. So now this, for all of posterity, people will be able to see that. And notice that this here is an interesting image. This is a burrito, apparently. And it snuck in there, and it really wasn't. But that's okay, because we want to be able to allow for these kind of errors. And this is the predictions that it's doing. Taco, burrito, it looks like it's doing a pretty good job. So that's the cool bit. Remember, the output of these things, like I told you before, is this actual model. And if we're going now from data scientists to software engineering and development, this is an actual artifact, like a DLL or a jar file, assembly, whatever. This actually represents a functional unit of something. And so we need to save them. And it turns out that in Azure Machine Learning, not only can we save them, but we can actually version them. So for example, here's Food AI version number 7, right? And it turns out that in this, we have some artifacts, and the artifact happens to be the Onyx file. Now, you can actually have more sophisticated models. Like, for example, here's a different one called Seer, and this one has multiple files in there. So a model represents the artifact or the output of a training, and you can actually save it here, which is super cool. So now it's not on some hard drive somewhere, on some share, it's actually here. And the other thing that's cool about this is that if I go to the model itself, it will tell you the experiment that generated it. So if I click here, we'll go back to the experiment that generated it. And so there's full traceability, which is really cool. Again, notice that I showed you, the thing I showed you when I ran it locally could be quite messy depending on how it's managed, because where do you put the files, how do we know where it's run, etc. The last thing that's really cool about this is that you can actually associate this with endpoints. So for example, if you wanted to deploy this model, you could totally do it. And so here's the Food AI model. And what it does is it maps the actual model to an actual way to score it. And what I mean by scoring is how to actually do inference or run it. So here's an example. In Azure Machine Learning, we have an init function. Notice it's loading the Onyx model. It's getting the model from the actual artifact if it's running in the cloud. And then when we run it, we basically get the image, right? It's a URL. I open up the bits. I push it through the actual Onyx model, and then I output the results. And what's cool about that is now I can pair the model with the scoring file and have this cool thing called an endpoint, which you see again right here. Now I'm going to go ahead and copy this, and I'm going to put it over here, right? And notice that it's like, I don't know what to do with this. But if I put in an image, so here's an image of I don't know what this is. Oh, well, it says burrito there. So I'll bring up this image here so you can see it. If I bring up this image of a burrito and I pass this to the service, so for example, image equals boom, notice that it actually runs the inference through the model, and it says, this is a burrito, and this is my confidence. And that's it. I mean, basically, what I've showed you is from a local run that we created locally, that I ran locally, you could move that into the cloud, and you can see that here in the actual experiments, right? Here's the Food AI experiments, right? A couple that have failed, a couple that were good. Here's one that ran that was good. You can see the experiments here. To the actual model, which you remember was right here, Food AI, to the actual endpoint, which represents the output of it. And so notice I've gone from something super simple that's running low, well, simple. It's a convolutional neural network, simple, to running locally, to running in the cloud and available for everybody. And I think that's probably the coolest part of using Azure, is that they've really thought about how to go from inception of the thing all the way to an actual model. And that's what I like about this process the most. And again, it's pretty simple. We are building an actual function that we call a model by pushing a lot of data into it. And so that's what I think is the coolest. And again, this has only been like 10 minutes worth. Obviously, there's a lot more you can do, but imagine being able to run any kind of machine learning thing in any way you choose, in any configuration, and have it managed this way for you.
Thank you, Seth. That really clears things up.
It's been my pleasure. I love talking about these things because the concepts are very simple. Obviously, when you build models, it gets a little more complex because if you want to know how they actually work and what's going on, there's a little bit of math involved. But it's not more complicated than we're building functions in a different way with data. And Azure Machine Learning is cool because it allows people to do this in a distributed way across a team.
Thanks again, Seth, for taking the time to talk to us. So we've completed step 1. We learned about what machine learning actually is and took a sneak peek into step 3 to see how we can create our own custom Entacco-Burrito model using Azure Machine Learning. Now let's dive into the second step and see how we can create our own custom machine learning model without doing the actual machine learning part. For this, I've invited my colleague Amy Boyd, also a cloud advocate at Microsoft. Hi Amy.
Hi Henk.
How are you today?
Oh, not too bad, thank you.
Thanks so much for joining me in this Developer's Guide to AI talk. Can you tell me what you're going to show to us?
Yeah, sure. So I know you've been speaking with Seth and he's kind of started you all on that journey of understanding a little bit deeper into machine learning, like what is it, how do we approach it? And so one of the things I said to Henk I thought would be really useful was to show you how I used a low code, no code tool to actually apply a bespoke machine learning algorithm to a problem that we were working on. And so this tool that I want to show you is actually part of the Azure Machine Learning service. So if you go into Azure, you type in machine learning, you create an instance of it, and then this is the data scientist platform. In here you can build models, you can use really powerful compute, you can store large amounts of data, and you can also deploy and look after these models as you move forwards. And so one of the things I wanted to show you was how I approached a specific problem using this tooling. Inside Azure Machine Learning is a feature or a part of the service called Azure Machine Learning Designer. And the Designer is a fantastic click and drag UI experience. So Henk, shall I jump into the problem that I was trying to solve and describe that to you?
Yes, that would be great.
Okay, so just on the screen here illustrates the company that we've been working with. So we've been working with Tailwind Traders, a fictitious retail company, and they do things like do-it-yourself, plumbing, garden, electrical tooling. Their amazing development team have created this fantastic website as well as an amazing native application. But with any kind of native experience or application or piece of technology, when it starts to get used by lots of different people and partners, often they might find issues with the application. And in the case of Tailwind Traders, they've created a support ticket system. So when any of these users have an issue, they submit support tickets to the system. Tailwind Traders also has an amazing support ticket team, and they triage any of these support tickets and route them in the right direction to get solved as quickly as possible. But unfortunately, these support tickets are flying in and they're getting a bit overwhelmed in the support ticket team. They did tell us though that actually a lot of people go away happy, their problem is solved quickly, and they can carry on using the application. But unfortunately, some people just aren't quite as happy with the service. They have long wait times and sometimes their problems aren't solved at all. And so the Tailwind Traders management team asked this question: how can we help the support team? That's it. Like a super broad question. Like in data science, sometimes it seems like you get a really, really specific question that points you exactly to how you're going to solve the problem. But this is actually the start of the business problem that we had, that we believed could be investigated and potentially solved using data science. And so the next thing I did was we went on and we had a look at their data. We worked with the support ticket team as domain experts, and then kind of said, right, I use tooling to explore the data. So things like Python visualization packages, but as well as like services like the Power BI service. I'm a huge fan of using that to explore my data. But one of the things after exploring it was I found that a few of the columns in the data set might actually be able to help us as we move forward. And so this is where Azure Machine Learning came into the equation. So a couple of things. When we looked at the support ticket data, for each line in the data set was a single support ticket, we found a column called duration. And so there was one idea that could we predict the duration of a support ticket when it lands in the support ticket system, so that we can understand how we need to staff the support ticket team moving forward over the next few weeks. So a demand type forecasting, but also there is a tag for escalations, and to kind of understand a little bit more about, is there an issue around escalations? Is it something that we can start to solve with machine learning? And so I'm in the Azure Machine Learning Studio here. If you go into azure.microsoft.com, create an Azure Machine Learning instance, and then go to the studio experience here by clicking the main button on the screen, this is kind of where you land. And if we look down the side here, we can see that there is actually this designer icon. So if I click on designer, it takes us to a page where we can see some of the designs that I've already created. But I want to show you how quick and simple it is to build machine learning models using this tooling, and how experimental it is. So if I click on new, I select how and where I want it to run. So I'm actually going to use some of the compute that's available to me and my team here. I can give this a name, so I can say support ticket team duration. And you may want to give it a description. Autosave is on, so anything I do from now will be accessible and ready to go. So I'm going to select my data set, which is this one, and I simply click and drag it onto the screen, and it tells me a little bit about it on the right hand side. So I can actually view that output just here, and we can see there's it tells you how many rows, how many columns, all the different features inside that data set, so we can explore also in here. But say I knew what I wanted to do, I can actually search up here for modules that I know exist, like the split data, and then I connect these modules together and fill in the parameters in order to split this data into training and testing data sets. I can then find different categories, like the algorithms. Underneath, we're doing a regression problem. I can click and drag an algorithm onto this workspace and actually use it with parameters preset for me. I also have training and scoring categories, so I can bring on a train, score, and evaluate model. And then I basically can just start connecting my algorithm diagram up. So we can connect our training data to our algorithm. We can tell the model that we're actually using the duration column here to train on. So we're trying to predict how long it will take the support ticket to be completed, given the information that's provided about it as it lands in the support ticket system. We're then going to use our trained algorithm and compare it against our test data, and it's not been trained on this data. And then finally, we're going to get some evaluation metrics. And then once I'm happy, I can click submit. I can create my experiment. So I do have one that is already here. So I can go down to support ticket regression duration, and I can click submit. It's now submitted to my compute instances, and it's going to go ahead and use that amazing powerful compute in Azure Machine Learning to run this experiment. So whilst that's running, I wanted to show you that actually once we create this, we can actually start to compare multiple algorithms together and just build out an experiment and find out which one was the best one. So if I go into evaluate results and click on the visualize, we can actually see the two different algorithms here. They're very, very close, so that is something that we would need to keep in mind. But for saying neural networks take a lot more processing often, we might want to stick with the boosted decision tree in this case. We can also then do things like, if we're happy with the boosted decision tree, we can use modules like tuning hyperparameters. So basically that will go through, do lots of sweeps of the data and test different parameters, and we don't need to set them here, which is a really, really effective thing. And then we can actually compare the before and after. And you'll note here that I've added a comment onto this so that I know exactly why and how we're doing things. And then finally showing that it's not just low code, no code. You can write Python scripts in here, and you can also output amazing graphics. So if we just open this up here, any Python visualization packages can be viewed inside here. And then also to note, it's not just regression and the basic algorithms that are up here. Do scroll down and you can check out things like text analytics, recommendations, and anomaly detection. So in this case, with the escalated example, anomaly detection is a really interesting scenario, because actually the data that we saw in the Python script showed us that actually there's not a lot of data around escalated cases. So really, is this picking up an anomaly? So in this example, I showed you how Azure Machine Learning Studio, and specifically the designer tooling, allowed us to create and experiment machine learning algorithms very, very quickly, and not having to write really any code to experiment with this amazing technology.
Thank you, Amy, for that great demo. And this also brings us to the end of this developer's guide to AI. So if you're a developer and you want to get started with AI, I recommend you doing 3 things. First, get yourself familiar with what AI is and how it works. Second, start experimenting with cognitive services or any other pre-trained models. Or start using the Azure Machine Learning Service Designer. And finally, start building your own models using Azure Machine Learning. Thank you for watching, and if you want to continue your learning journey, go to learn.microsoft.com.